Good morning, Tehmina Khan is here in TKMaths is fun. In today's video, we will solve a question on permutation and combination, which is a part of the syllabus of A-Level Mathematics S1. I have taken this question from June 21, variant 5 to question number 6. You can see my website address and my blog address here. You can visit it and find many useful videos. So according to the syllabus of permutation and combination, if you see here, there are basically 2 points and the rest are condition underneath. So in this question, we are covering almost all types. So you need to recall 3 basic concepts. One is of factorial. If it is n factorial, it means n times n minus 1 times n minus 2 and so on. Further, if there are like terms in the question, then you use this formula. For example, if the word is seed and I ask you to arrange it, there are 4 letters, so 4 factorial divided by, repeated is twice of 2, so it is 2 factorial. So in a word, as many times there are repetition, accordingly you keep dividing it by. So you have to remember these 2 very important aspects. And another one, permutation and combination. Permutation is where order is important. So, and combination where order is not important. So this formula will be given to you in MF 19 also, which will be the formula sheet. So you need to remember how to apply them. So let's see here the question. But before that, just want to show you that on my website address, under the heading of challenging question, I have put up all the topics. And these are basically links. If you will click on any, you will get to the videos which I have made on that topic. So it is a very good resource for your revision. Same thing is done on blog address also. Okay, so let's see this question. Find the total number of different arrangement of the 8 letters in the word tomorrow. Okay, whenever there is a word which has repeated letters, I would recommend write them separately. Like I like to write them like this. So at a glance, I know how many letters are repeated how many times. Now here it is, I have to arrange all 8 letters, right? So this is a case of factorial in which there is repetition. So it will be what? It will be 8 factorial divided by 3 factorial divided by 2 factorial. Why is it so? Because there are 3 O's and there are 2 R's, right? Now this case, part B. Now this question is actually overall tricky. There are 3 parts. This is part B. Find the total number of different arrangement of the 8 letters in the word such that R is at the beginning and R is at the end. This is condition number 1. And also in that arrangement, the 3 O's are not all together. Now this is a tricky part. So basically you see when you are arranging 8 letters, you are arranging such that R is in the beginning and end. And in between, when you are arranging the letters, 3 O's should not be together, all 3 of them. It means 2 can be together and none can be with each other. So we will handle this one by one. So condition 1, when R is in the beginning and end, we have written here. So this R is gone, right? Now, for the second condition, which is saying 3 O's are not all together. It means all 3 of them are separate plus the cases where 2 O's are together. So you will find them separately and add them up, right? That will give you the total number of arrangement. So we will see how many cases are possible when all 3 O's are separate. So let's see this left hand side. Now if you see this portion, right, this one, 1 2 3 4 5 6, there are 6 letters. Now out of those 6 letters there are 3 O's, right? So if I don't want them to be together, it means they have to become in between the other letters. So R's are coming in the beginning and end, they are fixed there. Now these 3 letters, which is T, M and W, they can come at any place. So I'm writing 3 factorial for that. Now this 4C3 is basically for 4 possibilities between here, here, here or here. Out of 4 position, O can come on any 3 positions. So I'm writing 4 C3. Now why I'm writing C here? Because O is an identical letter. So even if it switches the places, it won't make any difference. So that's why I'm writing 4 C3. So 24 total arrangements in which O's are separate. Now I have to see the cases here when 2 O's are together, right? What are the possible cases here? See here. If you see here in this arrangement, which I have written here again, here 1, 2, 3, 4, 5, 6. If O's are here, then the next place cannot be taken by O because only 2 O's can be together here. Or if O's are here at this end, then this place cannot be taken by O. It means these two types, these two arrangements have the same way to calculate. So let's see this one. Out of these 3 places, at this place only T, M or W can come. So I'm writing 3P1. And then these 3 places can be taken by any remaining letters, which are 3. I'm writing 3 factorial. Why I write here 2? Because there is another such case here when O's will be shifted at this end. Right? Now, what about the other cases when 2's are together? See here. Now, these 3 are of the same type. Why? Because earlier I considered when O's were coming in the, right after R or here before this end. Now, what about in between? These are the possibilities for O's in between. There are 3 such cases. So if I calculate the arrangement of one type, I will simply multiply it by 3. So let's consider this case. Now out of these 2 places, I have 3 letters which are T, M and T, W and M. So I'm writing 3P2. 3P2. Why did I write P here? Because T and M or W, whatever is coming here, they can switch places. So order is important here. So that's why I'm writing 3P2. And why I have written here 2 factorial? Because of these 2 positions. The remaining letter can come here and it will be 2 factorial. Then I write multiply by 3 because there are 3 such cases, 3 such arrangements because of the position of O which is changing. So at the end I got 24, 36 and 36. I will add it up. It will be equals to what? 24 plus 36 plus 36. So it will be 96. So there are 96 arrangement possible in which 3 O's are not together, all of them. Now this last part. Now you have to select 4 letters out of 8. After selection, you have to find the probability. So first of all, let's see how can we select 4 letters such that they have at least one O and one R. Now, the possibilities, because there are 4 letters we have to select, at least one and at least one R. So one case is when there is one O, one R, one O, two R, two O, 1 R, because we have total 3 O's and 2 R. 2 O, 2 R, 3 O and 1 R. Sum of this will be equal to 4, right? So these are the possibilities. Now let's start filling it up. So I have written here 1 O, 1 R, 1 O, 2 R, 2 O, 1 R, and you can see I have written here. Now how we will calculate the, because imagine these letters are in a box and you are selecting from there, right? So what is the chance of selecting it basically? Now if you see here, I have 3 O's, right? So for this one I'm writing 3C1 and for this one I'm writing 2C1. Why? Because there are 2 R's. I have written here also. And remaining letter are T, M, W and there are 2 places. So I'm writing 3C2. Similarly for this one I'm writing 3C1. For these I'm writing 2C2. And for this one 3C1. Similarly for this one, because there are 2 O's, 3C2 out of 3 O's. Then 2C1 because there are 2 R and you are selecting one. And then for this place, 3C1. Similarly, I have done here 3C2, 2C2, 3C3, 2C1. There is no other letter, so I am not marking it. So when you add it up, it is equals to 50. So there are 50 ways you can select 4 letters which will have at least one O and at least one R. Now we have to calculate the probability of it. These are just the selection, how many I can make out of 8 letters. We know probability is actually equals to favorable outcome divided by any 4 out of 8, because in tomorrow, the word tomorrow, there are 8 letters and we have to select 4, right? And favorable outcome is 50 here. So it is 50 divided by 8C4, and this is how you will get the probability. And in 3 significant figure, it will be 0.714. So thank you very much for watching this video. If you like it, press like and subscribe button and share it with your friends. Thank you. Take care.